Good day everyone, welcome to Kazmat's YouTube channel. In this video, I want to solve these simultaneous equations. I have two equations in modulus function in terms of modulus or absolute function. Now, in solving this, I'll use the knowledge of solving linear modulus function. A good example is if I have x minus 2 modulus of this equal 6. What you need to do in solving this is just say plus or minus. Instead of squaring, I believe squaring both sides is a good method, but it's a method that will waste your time. This is faster. Since I know what should be inside the modulus can be positive or negative of it, can be greater than 0 or less than 0. It's faster using that knowledge. So another example is if I'm solving this x minus 2 modulus of this equal modulus of 5 minus 6x. Is just to say x minus 2 plus or minus equal 5 minus 6x plus or minus. So you are going to get maximum of two values of x here. Likewise, this also maximum of two values of x. So that is what I'm going to use to answer this question. Let me use the knowledge of that to answer this question. Since it's a simultaneous equation and you have it written in terms of x, y given in terms of x for both equations, the best thing is to equate both equations, equate them together. Modulus of this equal 2 plus 3 minus 2x modulus of this. So we have two equations equated together. What I need to do now is to use the knowledge of what I've said. I can form the just equation where I can extract both the positive and the negative. Plus or minus x minus 5 equal 2 plus or minus 3 minus 2x. From this, I can form four equations. Yes, four equations from this. The first one is x minus 5 equal 2 plus 3 minus 2x. Let's say I've used both positive. Let me use positive on the left, negative on the right. I'm using a positive here. I'm using negative here. So that's what I'm using now. So I have x minus 5 equal to minus 3 minus 2x. This is the second equation. The third equation, I've used both positive on the left hand side. Let me switch to negative. Minus x minus 5 equal to minus 3 minus 2x. I'm using both negative. And the last one, minus x minus 5 equal to plus 3 minus 2x. I have four equations that I need to, four linear equations extracted from the modulus equation. With these four equations, I'm going to get four different values of x. In order to move on, after getting the four values of x, I need to check if the four values of x satisfy the two equations. So let me solve each of them one by one. The first one, x minus 5 equal 2 plus 3 minus 2x. Now in solving this, I have x plus 2x equal 2 plus 3 plus 5. So I have 3x equal 10. X is 10 over 3. Let me check with 10 over 3 in both sides. I want to see if 10 over 3 will satisfy both equations before I can move further to get y value. So let me substitute into the first one. Y is equal to 10 divided by 3 minus 5 modulus of this. This is negative 15. This is modulus of minus 5 over 3. This is 5 over 3. Let me put in the second equation. Now 5 over 3 is 1 point. One number 2 over 3, 1.67. Now, whatever the value of the second equation will be, there is addition of 2, which means is 2 greater than modulus of 3 minus 2x. So is 2 greater than this? which implies that it's going to be 2 plus whatever I get here, which is more than this. Therefore, x is equal to 10 over 3 would not satisfy. I can easily move forward and check the second equation. Let's check the second equation. The second equation is x minus 5 equal to minus, let me expand this, minus 3 plus 2x. So in solving this, let me subtract x from both sides, and also let me just subtract x. So I have negative 5 equal minus 1 plus x. This is what I have. So negative, let's say plus 1 plus 1. I don't want to put this, negative 4 equal x. X is equal to negative 4. So with negative 4, I can check if negative 4 satisfies the two equations given in terms of x, y given in terms of x. Negative 4 minus 5, I'm using this now. This is 9. Modulus of negative 4 is 9. Let me check the second one. 2 plus modulus of 3 minus 2 times negative 4. This is 2 plus modulus of 3 plus 8. This is 2 plus 11, which gives 13. Both are not the same. This is not the same. Y is not equal to 13. Therefore, the value of x equal negative 4 does not satisfy. I need to rub this, clean this, and move to the third equation. I've used two equations which did not give the right values. Let's go to the third one. Minus x minus 5 equal to minus 3 minus 2x. So here I have negative x plus 5, expanding this equal to minus 3 plus 2x. So I can say 5 minus 2 plus 3 equal 2x plus x. So here you have 6 equal 3x. Divide both sides by 3. X is equal to 2. I got a value of x to be 2. I need to check if this satisfies or not. Mentally, if I put 2 in the first equation, write it. But this gives 3. The second one also, y equal 2 plus, and put substituting in the second equation, 2 plus 3 minus was of 2 times 2. This gives 2 plus modulus of minus 1, which gives 1. This gives 3. So this is a good value. First x value is equal to 2. So since I've gotten the first x value to be 2, I need to get the y value and get the coordinates. It's a simultaneous equation where you need to get your x and y values. So I've gotten the first value to be 2. So let me get the y value. Oh, sorry, since the y value is the same thing for all of them, I made a mistake. I've gotten the y value. The y value is 3. The y value is 3. What I've gotten here is a y value, since it satisfies both equation. So which means I have 2 comma 3. So I have 2 comma 3 as one point, one answer, as one point where they intercept, which means they can intercept in 2 places or 1 place. So let's see if they intercept in the second value of x. Let's solve the last one. This is the last equation. This is the one we're solving on. I have minus x minus 5 equal 2 plus 3 minus 2x. Negative x plus 5 equal 5 minus 2x. So minus x plus 2x equal 5 minus 5. This is x equals 0. I got a value saying x is 0. Let me check if x satisfies the two equations. Y equal 0 minus 5. This gives 5. Modulus of negative 5 is 5. The second one, 2 plus modulus of 3 minus 2 times 0. This gives 2 plus modulus of 3, which is 5. So the second equation is also satisfied. We got the same answer, which is 5, 5. The second equation is also satisfied with x equals 0. So the second coordinate is 0, 0, 5. 0, 5 is the second coordinate to this 0, 5. So I got two values of x and two values of y. So I can write my answer as x is equal to 0 and y equal 5. Also x is equal to x was the second value, x is equal to 2. X is equal to 2 and or when y equal 3. So I've gotten the required values of x and y. Thank you for watching and don't forget to subscribe to my channel.